California's news leader.
From the Bay Area's news station.
A new research project at Stanford University is
Stanford is getting a lot of money to conduct independent research on energy and global warming.
The Global Climate and Energy Project, GCEP, is an unprecedented collaboration among the world's most distinguished energy researchers and experts.
It is a great pleasure to be here today for the inauguration of what promises to be a really important collaboration.
We're talking about changing the very manner in which we power the world. Think about the scope of that endeavor.
The energy transitions that will occur over this century will take decades to accomplish. There's much to do, but there is much that can be done, and the time to start is now.
Yes, I guess it was one of the first PIs within the GCEP program, which was very exciting. We did propose unconventional ideas and also unconventional partnerships, intellectual partnerships. Like in my case, I was able to build a partnership with a biological community, which I maintained as of today. This is a confocal microscope, part of our GCEP program. And this was an instrument which allowed us to extract photosynthetic electrons from individual plant cells. That was one of the nice things with GCEP that allowed us to engage in highly speculative thought. And with GCEP resources, we could do things which otherwise we probably would not have been able to do.
The goal of this project was to develop carbon-based materials as transparent electrodes for solar cells so that the cost for producing solar cells can be significantly lowered. We started this program working with carbon nanotubes. They have extraordinary conductivity, but the previous challenge has been that these little tubes are only a few microns in length. So in order to make a very large film that's highly conductive, electrons can need to move between these little tubes. The GCEP project allowed us to have certain discoveries that were licensed to the spin-off company from my group. In the future, we hope these kinds of materials can be used for solar cells and also solid-state lighting devices. When I have some radically new ideas, then without preliminary results, it's very difficult to get funding from the regular funding agencies. With GCEP, we're able to test out this type of high-risk but potentially high-reward project.
A promising technology for removing atmospheric CO2 is called geological carbon storage, and in this technology we take CO2 captured from coal-fired power plants and inject it into the subsurface as a storage option. And so the goal of our project has been to find ways to engineer these systems so that we can store the CO2 more effectively and more safely for longer time periods. So this is pure magnesium carbonate that formed naturally in the subsurface. And so one idea would be to inject the CO2 into these different rock formations and try to convert it into a carbonate instead of store it as a fluid. And in this way we would permanently lock up the CO2 as a stable mineral in the subsurface.
The basic objective of this program is to develop a new technology that enables to convert electrical energy into chemical energy. But we're using the capacity of biology, specifically of microorganisms, to produce interesting chemicals. So what these organisms typically do, they use CO2 from the atmosphere and use hydrogen and basically form methane as their end product, which allows them to grow and thrive. These hydrocarbons can be then used as fuels. They can be used in chemical industry to make new products, which can be then ultimately combusted. This is all in a CO2 neutral way.
JCAP is the Joint Center for Artificial Photosynthesis. It's the Department of Energy's Energy Innovation Hub in Fuels from Sunlight. The work sponsored by GCEP led naturally and was really the underpinnings of what became ultimately the foundations of JCAP. The work that we started in GCEP really enabled us to think about making not 10 compounds or catalysts in a year, but 10 compounds every minute. It led us to the concepts of how we might think about putting systems together that take sunlight and water and carbon dioxide and output chemical fuel as a system. This is exactly the kind of work that GCEP says its role in supporting should be, and in our case, it's come to fruition in a fine fashion.
Happy birthday to GCEP.
Congratulations to GCEP.
Happy birthday, GCEP. This has been an awesome program.